Absolute value inequalities. Okay, so let's take a look at an example or two of some inequalities involving absolute value. Believe it or not, this is one of those topics that continues to pop up throughout algebra courses, pre-calculus courses, calculus courses, and students have the hardest time with this topic. And I think in part it's because they don't truly understand what absolute value means and how to manipulate it when it occurs in algebraic expressions. So we're going to focus on examples like this. So how to solve something like 4 times the absolute value x minus 6 plus 2 is less than or equal to 30. So before we start, let's just talk about what absolute value means in terms of an inequality. So if we have something like the absolute value of x is greater than 2, what does that mean? So that means that the distance from 0 is more than 2. Right, so if we look at a number line, here's 0. So if the distance from 0 is more than 2, like here's 2, that means that those would be numbers, like 3, 4, 5, 6. All of those numbers would be more than 2 units away from 0. Since I'm using a strict greater than, we wouldn't include 2. It would just be, distances larger than 2. Since we're talking about a distance, it could be in either direction. So that would also include numbers like -3, -4, -5, and so on. All of those numbers would represent distances that are more than 2 units away from 0 on the number line. And that's what this means. So the absolute value of an expression is greater than 2. Looks something like this when you graph it. These are distances on the outside of the number line because we're looking at distances that are more than so many units from 0. So if I were to look at this as an inequality, I would say this side, looking at the right side, x values that are larger than 2. Since I want to include both sets, I would use the word or because that means everything that's shaded. X is less than -2, looking at the shaded region to the left. So the absolute value of x is greater than 2 breaks down to an expression like this. Likewise, if I'm looking at the absolute value of x is less than 2. So similarly, now we're looking at distances less than 2 units from 0. Okay, so if I'm looking at a number line, again, here's 0, here's 2, here's -2, and I want to represent all of the numbers that would show me a distance of less than 2 units from 0, that would be all of these numbers inside 0, in between 0 and 2. Or in between 0 and -2. So this inequality would be x values in between 2 and -2. Another way to look at this would be to say, focusing here on, I'm just going to change color. If we look at this piece of the statement, we could say x is less than 2. And looking at the other piece of the statement, x is greater than -2. So really what this represents is the intersection of two sets. So if you think about it, here's -2 and here's +2. So if I look at values of x larger than 2, or smaller than 2, excuse me. So here's 2, and I would shade to the left. and larger than negative 2. That would be here, and we shade to the right. Remember, and is the overlap, just the numbers that are in both sets, which in this case would be from negative 2 to 2. Again, same thing we saw right here. So that and statement is associated with the less than inequality, whereas the greater than statement is associated with the word or. So when I'm solving something like this, going back to our example, we have a less than, right? So this is going to be associated with the word and for this very reason that we discussed right here. The first thing you always want to do is you always want to isolate the absolute value expression first. So by that I mean let's get this piece of the equation by itself. So to do that, I'm going to take the negative 2 to the other side and divide both sides by 4. So this is 4 times the absolute value of x minus 6 is less than or equal to 30 minus 2 is 28. Divide both sides by 4. Absolute value of x minus 6 is less than or equal to 7. So now I have something similar to what I was explaining over here. It's a less than statement, so I'm really going to follow what we discussed down here. So really, I can go right to the double inequality with x minus 6 in the middle is less than or equal to 7 and greater than or equal to negative 7. Now I'm going to add 6 to all 3 sides. The goal when you're solving a double inequality is to get x by itself in the middle. So this becomes negative 1 is less than or equal to x is less than or equal to 13. In interval notation, this would be negative 1 to 13. Another way to look at this would be to set up the and statement. So we could have, once we're at this spot, another way to look at this would be to set up this and statement that we looked at down here. So to set up the and statement from this point, you always isolate the absolute value first. We could rewrite the problem as is. X minus 6 is less than or equal to 7, dropping the absolute value, writing the word and then rewriting x minus 6, change the direction of the inequality, and make that 7 a negative. So this is the same statement. Solve them both. X is less than or equal to 13, and x is greater than or equal to negative 7 plus 6, or negative 1. Notice this means the same thing. If I go to graph it, that's when I see that overlap. Negative 1 would be to the left of 13. Okay, so x is less than or equal to 13. That would be this way to the left. And greater than or equal to negative 1. So that would be this way and to the right. So if my solution is just the overlap, then my solution would be from negative 1 to 13. Notice I use the closed brackets because of the closed circles. Both negative 1 and 13 are in both sets. So again, 2 different ways to algebraically solve the same problem. Now, let's do an example of an or statement. In fact, let's just take the same problem. So if we took the exact same example but changed it to greater than or equal to, we would have the absolute value of x minus 6 is greater than or equal to positive 7. Okay, Notice when we're talking about greater than, like we did up here, you have to go right to the or statement. You can't write this as a double inequality because there is no overlap. So you have to rewrite this as an or statement. So again, take what's inside the absolute value, x minus 6, greater than or equal to 7. Greater than is always associated with or. X minus 6, change the direction to less than or equal to, and make that a negative 7. And now solve each. So x is greater than or equal to 13, or x is less than or equal to negative 1. Again, graph it to condense your statement and write your final solution. Negative 1, 13. X is greater than or equal to 13, which is going to be to the right, less than or equal to negative 1, which is going to be to the left. Again, this is or, so I want everything. I want both statements. My interval notation will be from negative infinity to negative 1, include negative 1, or 13 to infinity, and again, include 13.